Welcome back, and I've got another really fun experiment to show you today. What we're going to look at is the Magdeburg Hemispheres. So this wonderfully simple piece of apparatus goes back to about the 1650s, and it's named after Magdeburg, the city. Now, the mayor of that city happened to be a chap called Otto von Garrick, and he was a very keen scientist, and he devised this piece of apparatus to show audiences just how strong atmospheric pressure was. Von Garrick's demonstration of this apparatus was so spectacular, and I'll explain why in a minute, and he showed it to really important people, even Ferdinand III at the time. It actually had the effect of putting Magdeburg back on the map after being devastated after the 30 Years' War. So let's explain what this apparatus is, how we use it, and what it demonstrates. So this is a remarkably simple piece of apparatus. What it is basically a steel sphere, I think he used brass, that is cut in half. And we've got here a rubber seal, a vacuum seal. That's giving away the story a little bit. And if we put the two hemispheres together, there's a pipe here which we can connect a vacuum pump to. Now, obviously, we've got a modern one. Von Garrick would have had to have devised a much simpler vacuum pump. And once we've evacuated the air, we're now in a situation where there's air outside the container, outside the hemispheres, but no air inside. And it's what he did next that was incredibly spectacular. Okay, so I've got the vacuum pump here. Let's put the two hemispheres together and check that we've got a reasonably good seal. And if I let go, they just fall apart. So it's important you know that. And these ones are interesting. They've got a one-way valve here. So when we remove air, air can't get back in. And there's a bleed valve here, which basically opens it to the atmosphere. So this would let air back in. Now, the way I do this, so I don't pinch my skin, is I try to hold the hemispheres like this, connect up to the vacuum pump. There we go. Turn on the vacuum pump. Line up the two hemispheres, and then once I've got them lined up, I seal the air bleed valve. And the vacuum pump's doing its job of removing the air from the system. So what I'll do now is I'll turn off the vacuum pump, and we'll see what happens when we try to pull these two hemispheres apart. Okay, so let's disconnect the vacuum pump. And you'll notice now that the two hemispheres are completely stuck together. There's no chance of me pulling these apart at all. And this is what von Garrick knew. And to demonstrate it in his spectacular public displays, what he did was he took his two hemispheres, evacuated them, and then attached gangs of horses to them. The records suggest that one demonstration, I think it was the first major one he did in front of royalty, was he attached 30 horses to this. So that's 15 pulling that way and 15 pulling that way. And they still couldn't separate the two hemispheres as long as there was a vacuum inside and atmosphere on the outside. So this is going to take a little bit of explaining. So I hope you know that the atmosphere is made up of gas particles, and where we are on the Earth's surface, we talk about the atmospheric pressure as being about 1 atmosphere. That's 100,000 newtons force per metre squared, and that's totally crushing. So that's the force of the air molecules, that's the nitrogen and oxygen, hitting the outside walls of these hemispheres. But because there's no air inside, there's nothing forcing them outwards. So they're pushed together with phenomenal forces. And it's those forces that the horses couldn't overcome. Now, atmospheric pressure is absolutely crushing. And you might ask, well, why don't we get crushed? Well, of course, we've got air inside us as well. So as much as we're being crushed inwards, we're also being pushed outwards. And those two forces are equal and opposite. And those two pressures, therefore, balance so we don't feel crushed. And to show you that, let's now let a little bit of air into this. So I'll bleed some air in. And now we've got an equal pressure hammering it inwards and an equal pressure inside pushing it outwards, and it just falls apart easily. So let's evacuate our Magdeburg hemispheres again, and this time I'll take them to the other side of the lab and we'll put a rather larger load on them. Okay, so let's hang up our evacuated Magdeburg hemispheres. There we go. And I haven't got any horses to play with today, and I don't want to put a huge amount of weight on it, but I've got, 7 kilos here, so 70 newtons, and we'll just pop that on. And I know that a load like that is much, much smaller than what's needed to overcome the atmospheric pressure holding these hemispheres together. So just to show that I'm not cheating, I put a slightly smaller load on this so I can catch it. And over here is the air bleed screw. So what I'll do is, I'll probably hold it here, it's probably a safer place. I'll let some air in. Can you hear it going in? There we go. And now we're back to, and that's the seal, the vacuum seal that's in there. We're back to atmospheric pressure inside the hemispheres and outside. So they're not being forced together by the atmosphere and they separate quite easily. So I do hope you enjoyed that experiment and learnt a little bit more about atmospheric pressure. I'll be making another video soon, and I look forward to seeing you then.